Section 3.4 is on solving problems using acute triangles. So problems in trigonometry can be solved using SOHCAHTOA, the sine law, the cosine law, or a combination of these. In all of these cases, though, you need at least 3 pieces of information, and one of them must be a side length. So you basically look at the information you got and decide which is the best method to use. So for example, if you have a right triangle, you would usually use SOHCAHTOA. If it's a non-right triangle, you have to decide whether it's going to be the cosine law or the sine law. And I usually just remember that the cosine law is used when you have SSS or SAS. Otherwise, try the sine law. These are the cases specifically where you'd use the sine law, AAS, ASA, or SSA. But it's just easier to remember SSS and SAS go with law of cosines. The other ones usually go with the law of sines. So let's try a couple of examples. So the first example here says, in preparation for an outdoor concert, a stage crew must determine how far apart to place the 2 large speaker columns. Use the diagram below to determine the answer. So these are the speaker columns right here, this one, and we need to find this distance right here. So if you look at the information you've actually got 2 sides and 2 angles. So that's you can look at that as SSA information, side, angle, or the other way, side, angle the other way. So you should be able to use the law of sines there. And when you set up the law of sines, you have sine of 50 degrees over the side across from it, which is 10, should equal sine of, we need the angle across from x. We don't have that angle, but we can easily figure it out because we know that 3 angles of a triangle add up to 180. So if we know 2 of them are 50, and we take that sum, 180 take off the 2 50-degree angles, we will end up with 80 degrees for the last angle there. So sine of 80 over x. And then we can cross multiply to find x, and we get x sine 50 is 10 times the sine of 80. So x sine 50 equals 10 times the sine of 80, which is 9.848, 1 if you round it off to 4 decimal places, and then you would basically want to get x by itself, so you divide both sides by the sine of 50. X would equal 9.8481 divided by sine of 50, and that gives you 12.8558, or to the nearest, it doesn't say how to round it off, so we'll round it up to nearest tenth, I guess, 12.9 feet. Now this particular problem, you could also use the law of cosines, because when we figure out that angle here, we're looking for x, and if we know that this is 50 and this is 50, and we can figure out this one is 180 minus the 50 minus the 50, which we said was 80. And then we also know that this is 10 and 10 here. So you also have SAS information if you look at this side, this angle, and this side. So you could also use the law of cosines there. So this is another way to solve it. This particular one has enough information that you can use either one of them. So if you use the law of cosines, you'll be using the side squared equals the other two sides squared and added together. Subtract twice the product of those two sides that you know, times cos of the angle across from the side you're looking for, which is the 80-degree angle. And that's going to be 100 plus 100 minus 2 times 10 times 10 times the cos of 80. And make sure your calculator's in degree mode again. 34.7296. And if you subtract or add 100 and 100 and subtract 34, you'll get 200 minus 34.296, which is 165.2704. So x would equal the square root of that. Which equals 12.9 as well. Well, it's 12.8558 as well. If you round it off to 4 decimal places and to 1 decimal place, would be 12.9 feet. So either way you get the correct answer. Try another example now. The second one here says a group of college students are learning to navigate for an upcoming survival trip and they need to determine the angle measurements. Calculate the measure of angle S for them. So here's angle S in our diagram. And if you look at the information, you have SSS. So therefore, that means law of cosines is what we'd use. So in this case, we don't have a choice. There is only all we have is 3 sides. We have no angles at all, so we have to use law of cosines. So the law of cosines, when we're looking for the angle, it will be cos of the angle that we're looking for. So we'll call this, I'm not going to use S, I'm going to put theta there because sometimes people think the S's are 5s and then they get confused. So cos of theta equals 30, the two sides that we know, 31.6 squared plus 22.4 squared, the two sides that we know that are around the angle that we're looking for, and you always subtract the side across from the angle squared. And then it's always 2 times whatever these two are here, this one and this one. So 31.6 times 22.4. And that would equal 998.56 plus 501.76 minus 2,043.04 all over 2 times 31.6 times 22.4 is 1415.68. So you get cos of theta equals, if you put that, simplify the top there, 998.56 plus 501.76 minus 2043.04. You get negative 542.72 over 0.68. So the angle would equal the inverse cos of that. Over 115.68, and so put that in your calculator. Inverse cos of negative 542.72 divided by 1415.68, and keep brackets around that if your calculator puts it in the way it's written there. and that gives you approximately, if you round it up, it gives you 112.542, so on. So that's approximately 100 and, doesn't say which would round it off to the nearest degree, it would be 113 degrees. Okay, the next question says the first hole at a golf course is 210 yards in a direct line from the tee to the hole. So here's the tee, here's the hole, so this is 210 yards. That's the straight line distance. Jack Top hits his first shot at an angle of 15 degrees off the direct line to the hole, and the angle between his first shot and his second shot was 105 degrees, and those are marked in the diagram for you. His second shot landed in the hole, so it's asking you to determine the length of his second shot, which would be this distance right here, from here to here. So if you look at the information you have to work with there, in this case you've got angle, side information. So you can use the law of sines, because it's not SSS or SAS. So therefore try the law of sines. So we would set that up as sine of 15 degrees over the side that we want as x. And then we got to use another angle in the triangle, which is 105. And we do have the side across from that. So that would be sine of 105 over 210. Those two should equal each other. And then we can just cross multiply and get x sine of 105 equals 210 times the sine of 15, and then work that out. 210 times the sine of 115 would be 15, sorry, not 115. 210 times the sine of 15 would be 54.35 199, so on. So x would equal 54. Keep writing down 54.35199, so on, over sine of 105. Because you divide both sides by sine of 105 to get rid of, just get the x by itself. So when you work that out, you get, so I have that still left in my calculator, so divide that by the sine of 105, and you would get 56.2693. 56.2693. Okay, we're come up with 7. 2693. So it asks you to determine the length of his second shot, so we round that off to the nearest yard, or nearest tenth of a yard. It would be 56.3 yards. So question number 4 is basically a diagram where you have more than one triangle involved, and sometimes you might be asked to find a piece of information where if you look at the triangle that it's contained in, you don't have enough information, but it's attached to another triangle which you can figure out a common piece that will allow you to get to the piece of information you want. So question 4 kind of goes through a step-by-step process of, eventually we're going to be asked in question C to find the length of LP. So the first thing we do is they're asking you to find the length of MN. So MN is right here, and I'm just going to put an X rather than an L because there's a couple of sides, a couple of triangles that have vertex L. So X is just the segment from M to N. So when we look at the triangle that X is in, it's in triangle L, M, N. And that triangle has side, angle, side information. So we're going to use law of cosines. So law of cosines, we're looking for a side length, and the side length squared would equal the other two sides squared and add it together. And then minus twice the product of those two sides times the cosine of the angle across from the side we're looking for, which is the angle contained between the two sides we know. So if we work that out, we get 64 squared is 4,096, and 51 squared is 2,601, and then 2 times 64 times 51 times the cosine of 24 is 5,963.6247 approximately, and then we add those up. So 4,096 plus 2,601 minus 5,963.6247 is 733.37525, so on. So this is x squared now, don't forget. So if we want to find x, it would be the square root of that. Which is approximately 27.0809, or approximately to the nearest tenth of a centimeter. You're asked to find, which is 27.1 centimeters. So now if we move to part B, they want us to find the measure of angle, LMN. And LMN is right here, L to M to N. So we can fill in the 27.1 that we got above, and if we're looking for this angle here now, we can again use the law of cosines because we got side, side, side. We could also use actually the law of sines if we wanted to, but it's this particular case, it's probably a little bit easier to use the law of cosines. So the law of cosines, you got SSS, so that means law of cosines. So we've got this angle that we're looking for would be cosine of angle M, and it should equal the squares of each of the angles that are around, each of the sides, that are around the angles, 64 squared plus 27.1 squared, minus the side across from that angle squared, all over 2 times 64 times 27.1. And that's going to give you 4096 plus 27.1 squared, 734.41 minus 51 squared is 2601, all over 2 times 64 times 27.1, and that gives you 3468.8. So cos of M equals, work out the top, 4096 plus 734.41 minus 2601 is 2229.41 over 3468.8, and that means that M is the inverse cos of that value, And if you use brackets again, you don't have to work out 229.41 divided by 3468.8. So inverse cos of that value would be of 2229.41 divided by 3468.8. And that gives you about 50.006, so approximately 50 degrees if we round it to the nearest degree. Okay, so the next or last part of the question is now to work to find the side LP. So if we look at what we have here go back up to that diagram, if we take the triangle and just take the part that has LP in it, this is L, this is P, this is 51, and we're looking for this right here, so we put an X next to that. And we also have, just draw the rest of that. Sorry about the horizontal lines seem to work straight, but any other lines go squiggly. So we just found out that M was 50 degrees, and we also know that this is 24. So if we're trying to move to this right triangle LNP, and this is M over here, we can figure this angle out first. This angle would be 180 minus the 50 minus the 24, because all three angles of triangle LMN should add up to 180. So 180 minus the 50 minus the 24 gives you 106. And then once we know that this is 106, we can figure this one out, because that would be 180 minus 106, and that would be 74 degrees, because they form a straight line, and straight lines have a measure of 180 degrees. Two angles that form a straight line have a measure of 180 degrees, so that would be 74. And then we can move to the right triangle, triangle LNP is a right triangle. So that means we can use SOHCAHTOA now, because we have enough information. We can use sine of 74 degrees. There's the 74 degrees right here, equals opposite over hypotenuse. So sine of 74, in this case the opposite is x and the hypotenuse is 51. And then we can just cross multiply that to get x equals 51 times the sine of 74 which is 49. So that's about 49, was 49.024, so it's about 49 to the nearest centimeter, so 49 centimeters. Okay, the next question is another question where there's more than one triangle involved, and you're asked to find the measure of angle QSR, which is right here. But QSR, if you look at the triangle QSR that contains that angle, you only have two sides and that's it. So that's not enough information, because you need at least three pieces of information. However, if you look at the diagram, this triangle QSR and the other triangle QPS both have this side in common, QS. So if we move to the triangle PQS, we can see that it has the information of angle, angle, side. So that would be the law of sines. And if we set that up for triangle PQS, we would have sine of 71 over 7.3, because we know the side across from angle 71 is 7.3. And we really want to get x involved, so we would rather have angle P and work with that rather than angle Q. So we do have two angles in the triangle, so it's not hard to get angle P, because angle P would just be equal to 180, subtract the 50, and the 71. So that would be 180, subtract 50, subtract 71, and that will give you 59 degrees. So angle P would equal 59 degrees. So if we come back over here then, don't like that, I gotta fix that. Okay, so angle P is 59 degrees, so then we can use sine of 59 degrees over the side that we want, which is x. And now that we've got that, we can cross multiply. And we've got x sine 71 equals 7.3 the sine of 59 times the sine of 59. So x times the sine of 71 equals 7.3 times the sine of 59, and that gives you 6.2573. And then you would divide both sides by sine of 71. And that gives you, these are cancel, and x would equal 6.2573 divided by the sine of 71 would be 6.617, no, 17, sorry. 1787. So on. So if you round that off to, it doesn't say, but we'll round it off to 1 decimal place, is approximately 6.6 centimeters, because the other sides have 1 decimal place. So we're not finished yet, because we're actually asked to find QSR, angle QSR. But now that we have 6.6 centimeters, now we have SSS in triangle QSR. So that means law of cosines can be used. So if we set up the cosine, and I'm going to put a theta symbol there so that you don't think my S is a 5. So cos of theta equals the two sides around the angle that you're looking for, which are 4.8 squared, plus the other one is x that we just found, which is 6.6 squared, minus the side across from the angle that we're looking for squared, all over 2 times the 4.8 times the 6.6. I'm running out of room here, so I'm just going to try to squeeze this in. So I'm going to do all this at one time to calculate. 4.8 squared plus 6.6 squared minus 5.2 squared is 39.56. Over 2 times 4.8 times 6.6, 63.36. Which means that the angle is the inverse cos of that. Which is inverse cos of 39.56 divided by 63.36. And that's about 51 0.34 or 364, so 51.364, so that's about 51 degrees approximately. And the last question that involves two triangles again. We have, on June 30th, 1956, the world's largest freestanding totem pole, so AC represents the totem pole here in the diagram, was erected in Beacon Hill Park in Victoria. Recently, a survey took measurements to verify the height of the totem pole. In the diagram, triangle ABC lies on a vertical plane, so therefore you got AC perpendicular to CB in the diagram there, and triangle BCD lies on the horizontal plane, so that's kind of on the ground. So determine the height of the totem pole. So again, if you try to use the right triangle ACB, you don't have enough information in it. You only got one angle. So it would be helpful to probably find this side CB here using triangle that's on the ground DCB. Now in the triangle that's on the ground, triangle DCB has ASA, sorry. Has A angle, side, angle information. So that means law of sines is going to be used, because SSS and SAS go with cosines, or the other ones usually go with law of sines. So we're going to set that up so that we can find x. So now if you look at, we've got sine, we want to use sine of 61 over x, because we want to find x. The other one we'd like to use is this angle here, because we have this side. And that's not a problem, because even though it's not given, we can easily figure it out using the sum of the angles of a triangle have to add up to 180. So 180 take off the 61 degree angle and the 42 degree angle. Should tell you what's left for that angle that we're missing. So 180, take off 61, take off the 42. Gives you 77. So now I can go down here in my law of sines formula and use sine of 77 degrees over 27.2. And then once I got that set up, I can cross multiply, and that's going to give me x times the sine of 77 equals 27.2 sine of 61. So x sine 77 equals 27.2 times the sine of 61, which is 23.78965, so on. So x sine 77 and it said the dot 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 just indicates I just wrote down some of the digits that came up on the calculator. So I'm going to want to get x by itself, so I got to divide both sides by sine of 77. And that gives us x equals 24.415 24.4154, which is, if I round it off, say to one decimal place, 24.4 meters. So now we can move to the right triangle, A, B, C. We've got, this is what we want, the height of that pole, and we know that this is a right angle, and we know that this side here we just found that was 24.4, and we're told that this is 58. So we can use, this would be the opposite and the adjacent sides of that right triangle. So we would use tan. Tan of 58 degrees is opposite is h over adjacent would be the 24.4. This would be your opposite. And this would be your adjacent to that angle that you got. So that would be put over 1, cross multiply, or multiply both sides by 24.4 if you want just to isolate h, either way. Most students cross multiply, so 24.4 tan 58, which equals 24.4 times tan 58, which is 39.04801, so approximately 39 feet, is it, meters? Okay, so there's some questions there on pages 161 to 163 that you can try to practice some of the topics that we learn in this section.